Hello, judges. My name is Nate Nellis, and I'm going to be going over the 3 cards that I built using Domo to analyze the COVID-19 dataset from South Korea. The dataset goes until almost the end of March. It's been about 2 weeks from today, and since we've had data. And since things progress so fast with this virus and with the situation of the world, this data may not be accurate to today. And in the future, as we keep going and down the weeks and hopefully not months, there will be more information we can glean. The nice thing about Domo is we can just keep updating the data set, and it will feed into the views that we have, so we can keep learning more and more. The first card that I wanted to look into was a provinces heat map. As you can see, this is South Korea with each province, and then the color is darker based on the number of cases. As you can see, there's a huge standout among these provinces, which is Gyeongsangbuk-do. And please forgive my pronunciation of South Korean names. But as you can see, this one province accounts for, here it says 42% of the cases in this entire data set, which is a lot. I mean, even the capital here, Seoul, is not even close, which is interesting and not something we would typically expect. And so as a researcher or as a government agent wanting to conduct policy, we want to know what makes Gyeongsangbuk-do different from the rest of the provinces. What things are happening there that will potentially lead to more hotspots in other places. If we click into these graphs, we can do drill downs, which is a feature that Domo has, or we can look at this filter here, which is on the province of Gyeongsangbuk-do, and we can see the different cities that are in the province. Just kind of like we saw previously with the whole country, there's one city in this province that stands out from all the rest of them, which is this one, Gyeongsang-si. It has about 50% of the cases in this province in just this one city, which is a lot. I mean, the next city is about 1/10 of the number of cases. And so again, we also want to see what is making this one city to have such a huge effect. Why is this city a hotspot? And what attributes do other cities have that are similar to this city that we can learn where the next hotspots may be, so we can be preemptive about curbing the spread of this virus? One thought that I did have was looking at Daegu, which South Korea says is kind of the epicenter of where this started in their country. Here's Daegu, and here's Gyeongsang-si. As you can see, they're very close to each other. So it's interesting that Gyeongsang-si has so many more cases than Daegu has, even though Daegu is where it kind of started. So we kind of want to look at the attributes that Gyeongsang-si has, so we can figure out where the next places are going to be, what we can do to help curb the spread. With this view, we can then click to drill down again, and this takes us to a graph that shows some of the different places that people were infected from. And we can see even more by removing this filter and just keeping the whole province filter here. Looking at these, we can kind of see that there's definitely a lot of contact between people, which we can't really change or avoid. What's interesting is that we have this nursing home, we have this nursing home, we have multiple churches as well. So it's interesting to think about these places may be hotspots, and we want to look out for them. And so this drill down can help us learn from this one city where, or this province, where are the cases coming from, where is spread happening, and we can help us as we look forward to curbing the spread in other places. Unfortunately, we do have some data discrepancies, especially this ETC category, which accounts for most of the cases. So hopefully in the future we can get more accurate data so we know what this huge chunk actually means. Going back to our overview, the second card I want to look at is a cases over time card. This is a bar chart that's progressing, and it shows on each day how many cases of COVID-19 were confirmed on that day. And as you can see, At about the middle of February, there's a huge exponential increase, which happens. What's interesting, though, is it only happens for about 2 weeks. And then after March 5th, which is where the peak is here, we can see that it decreases to be about the 50s range or less for the most part, and it stays around that point. We would normally expect it to stay high a lot longer. So this just goes to show that South Korea was preemptive, their strategies were effective, and we need to learn from what they're doing. Just like in the previous card, this one has drill downs. So I'm going to select this day with the most cases so we can learn a little bit more about what's happening there. This leads us to a graph where it shows us for each decade of people, how many or the percentage or the portion of that group were each gender. What's really interesting, I thought, was how many females there are here. There's the lowest here is about 60% here in the 20s, but it can be as much as 85% here, where most of the people who are getting infected are female. That's super interesting, and we probably need to look into that more to understand why are females getting more infected. Is it the activities they're doing, the kind of work they're doing? We need to figure out what they're doing that causes that to happen. We can further drill down into this, and this gives us this graph, which shows the split in the ages. So the previous graph was for each portion of people, what like the proportions of that group. This one just looks at the number of cases. And taking away this day filter, just so we can get a better picture, we can see that most of the cases, about 70%, are below the age of 60. And the people who are 60 are more high risk. That's good to note. But there is something interesting to see as well. So as I go and drill down further, this graph shows the percentage of people who are 80 who contracted the illness who died. So we can see that this one is about 8% of the people who contracted die. Taking away the age so we can kind of see everybody. What's interesting here is that for females, basically nobody's died under the age of 50. And they're the people who are contracting it the most. So it's very interesting to note that. And we can see there's a huge increase with these higher ages. We can do the same activity looking at males or the whole population. And what's interesting is, so if you watch as I take off this filter, you'll see that these red bars increase a lot, which shows that males are actually more prone to die from the disease, even though more females are getting infected, which is a very interesting insight that we need to look into more to understand how to best serve the people so that less people are dying and getting infected. Our last card that we have has no drill downs, but I thought it was a very interesting card. This shows for each day, if you were infected on this day, how long would it take for you to be treated and then leave the hospital and be stated as recovered? So as you can see, towards the beginning, it's pretty all over the place, but at about the 21st of February, that number decreases until the end of the data set. So here on the 21st, it's 25%, and by the end, it's about 14, which is really interesting because it shows that this whole area here is decreasing. And that, I think, shows that South Korea, the things they're doing are working. They're getting people tested a lot quicker. They're getting people treated and into hospitals a lot quicker. And they're able to release them quicker because of the actions they're taking. We can definitely learn a lot from all of these graphs to know exactly what is causing things to happen more. And I mean, we here don't have all the information that they have there. So hopefully researchers there can take a look at these specific cities or these specific subgroups and figure out what are the things they're doing that's causing this virus to spread more. We can hopefully learn so that in the future we can decrease the spread of the virus. Thank you for listening to my presentation, and we'll see you.